Hello everyone, this is Rani, and in this video I would like to discuss about interpolation topic, in which first one is Newton forward formula. Okay, so before starting with this Newton's forward formula, let us try to understand what is interpolation. So what is interpolation means whenever the two characteristic values are provided in a tabular format like x and y, okay, and these y and x are correlated with the relation y is equals to f of x. Fine. So for different values of x, we are going to have different values of y. 4, 5, 6, 7, let us consider. Okay. So what happens, you see here, we are able to analyze like for x equals to 0, the y is becoming 4. For x equals to 1, the y is becoming 5. And for x equals to 2, the y is becoming 6. For x equals to 3, the y is becoming 7. So if I want to know for x equals to 1.2, what happens to the y? What the y will be. Otherwise, if x equals to 2.9, what the y will be. So the procedure of finding out the y value for different values of x which are lying in between the given x values is nothing but a interpolation, right? So in this interpolation, again we are going to have few methods. The very first one is Newton's forward formula, and next one is Newton's backward formula, and Lagrange's method also. So if we let us try to understand what is this Newton's forward formula mean. And first of all, Newton's forward formula will be utilized only when the given x value is lying in the first half of our given x values. Means if whatever the x values are provided in the table like 0, 1, 2, 3 should be divided into two equal halves. So if the asked x value is lying in the first half here, then we should go with the Newton's forward formula. If it lies in the second half, we should go with the Newton's backward formula. Even okay. So for that, let us see this Newton's forward formula. What does this Newton's forward formula mean? P of x equals to means whatever the function is existing, the relation between x and y, that is nothing but P of x. Otherwise, it can also be denoted with f of x, g of x, anything. So here we have chosen P of x. So P of x is equals to y naught. And one more point, let us try to understand what are all these terms like y naught delta, y naught delta square, y minus 1 and all this. Okay. So to understand all this, first, we should know about forward difference table. What does this forward difference table mean? So forward difference table mean like this. If x values and y values are provided, like x values, y values, x values are 0, 1, 2, 3, 4. And the respective y values are 4, 9, 15, 18, 21. Okay. So here forward formula we are using. So we need to generate a forward difference table. So what is this forward difference table and what are forward differences? So forward differences are denoted with an operator delta. Okay. So what are the differences? Before going for differences, let us learn notations here. So we can consider this notations as you see the values of x as x0, x1, x2, x3, and x4. And y values as y0, y1, y2, y3, and y4. Okay. So now we are finding out the forward differences. First forward differences are nothing but delta y. Second forward differences are delta square y. Third forward differences are denoted with delta cubed y. And fourth forward differences are denoted with delta power 4y and so on. So depending upon the data, we are going to have all this set of forward differences. So first forward differences are defined as how? Y1 minus y0 and y2 minus y1, y3 minus y2, y4 minus y3. These are first forward differences. So what are the values we get here? Y1 minus y0 is 5 and 15 minus 9 becomes 6 and 18 minus 15 is 3, 21 minus 18 is 3. Okay, so in this way, the first forward differences should be calculated. Next, second forward differences should be calculated. So now here this is called as delta y naught. This is delta y1. This is delta y2. And this is delta y3. So what does this mean? Delta y naught is nothing but y1 minus y naught. And delta y1 is nothing but y2 minus y1. Delta y2 is nothing but y3 minus y2. Delta y3 is nothing but y4 minus y3. Okay, so in the same way, we are supposed to find for second forward differences delta square y naught and delta square y1 and delta square y2. And third forward differences delta cube y naught, delta cube y1, and fourth forward differences delta power 4 y naught. So let us try to find out what are these like. Difference between delta y1 and delta y naught is nothing but our delta square y naught. That is my 1. Next, delta y2 minus delta y1 is nothing but delta square y1. That is minus 3. Next, the difference between delta y3 minus delta y2 is 0. That is delta square y2. These are second forward differences. Now third forward differences. The difference between delta square y1 and delta square y naught is nothing but delta cube y naught. That is nothing but minus 3 minus 1. That is minus 4. Next, the difference between delta square y2 and delta square y1 is delta cube y1. That is nothing but 0 minus of minus 3 becomes 3. Next, fourth forward difference. What does this fourth forward difference mean? Delta cube y1 minus delta cube y naught is nothing but delta power 4 y naught. That is 7. So like this, we need to find out first forward differences. So from this, we understood what are forward differences. How many kinds of forward differences are there? So first forward differences will be there. Second forward differences will be there. Third forward differences will be there. Fourth, fifth, and so on. So depending upon the given values for x and y, we are going to have these columns, nothing but a forward differences. And this entire table is called as forward difference table. What it is called as forward difference table. This is called as forward difference table, and forward difference operator is delta. Forward difference operator is delta. Okay. So after understanding about this forward difference operator and notations like y naught, y1 and all, now let us try to observe one simple point here. In each and every column, we are going to have beginning values as same suffices. This is y naught, delta y naught, delta square y naught, delta cube y naught, delta power 4 y naught. Means from the forward difference table, all the beginning values of all the columns will be utilized in Newton's forward formula. Okay. And one more point had to be noticed is, as per our knowledge, we know that what is this NCR? What is this NCR? Whenever our number of elements are being selected from n elements, the number of ways we are selecting can be written as NCR. NCR is nothing but n factorial divided by r factorial into n minus r factorial. So this also will be utilized. So now let us move on for the Newton's forward formula, our actual topic. So after understanding for this forward difference table and forward differences, okay, let us check with our Newton's forward formula and how this Newton's forward formula will be utilized in calculation of y for the given x values. So what is this? This P of, in brackets, P1 is given. This is called as NP1, NP2, NP3. Right. So now let us understand this formula now. So first one is y naught plus, this is written as P divided by 1 factorial into delta y naught plus this P2 is there. No, this is nothing but p into p plus 1 divided by 2 factorial into delta square y naught. Similarly, the next one will be considered as p into p plus 1 into p plus 2 divided by 3 factorial into delta cube y naught plus p into p plus 1 into p plus 2 into p plus 3 divided by 4 factorial into delta power 4 y naught plus so on. So depending upon the values obtained from the difference table in the question, we are supposed to take the number of terms in this formula. So either this representation or this one will be utilized as a Newton's forward formula. Okay. And after knowing about Newton's forward formula, let us see one example. So here they have given x values and y values. You see, x values, y values. So what we are supposed to consider? This is as y naught, this as y1, this as y2, this as y3. Okay. And our Newton formula is y of x is equals to, as we have discussed, it's y naught plus p. Here they have taken as n. So p or n, anything we can take as a notation here. So p divided by 1 factorial into delta y naught plus p into p minus 1 divided by 2 factorial into delta square y naught plus p into p minus 1 into p minus 2 divided by 3 factorial into delta cube y naught plus p into p minus 1 into p minus 2 into p minus 3 divided by 4 factorial into delta power 4 y naught. So keeping this formula in our mind, let us try to find out the difference table first. Okay, so y naught minus y1, delta y naught, and y2 minus y1, delta y1, and y3 minus y2, delta y2. And delta y1 minus delta y naught is delta square y naught, and this is delta square y1, and this delta square y1 minus delta square y naught is delta cube y naught. So we need to calculate the differences until we get a single value in the table. So in the column delta cube y naught, we got a single value. So let us stop this difference table here with this column. So after writing all these notations, next we need to find out this p value. So what is this p value? P is defined as x minus x naught divided by h. Okay. So what is this x value? X is nothing but for which value of x we are trying to find out y, that is x. So here we are trying to find out the polynomial. We are finding out polynomial. So in the case of polynomial, x remains x only. X naught is nothing but the initial value of all x values is x naught. H is nothing but the difference between two successive x values. So 0 and 1 difference is 1. So here h is 1, x naught is 0, and x remains as it is x only. Okay, so therefore, after this, if you substitute all these values like p, delta y naught, delta square y naught, delta cube y naught, in the Newton's formula, we are going to have this polynomial. You see, we have taken y is equals to y naught, this p by 1 factor into delta y naught. Instead of p, here they have taken n. So n into n minus 1 by 2 factorial into delta square y naught. We have all this, you see. Right? So therefore, we need to substitute all the values here. P is equals to x. Why? Because x minus 0 divided by 1 is x. So P is equals to x. X by 1 factor into delta y naught is 1. Delta y naught. What are the values we want? Y naught, delta y naught, delta square y naught, delta cube y naught. And this P. So let us substitute all those and simplify for the cubic polynomial. So here in this question, what we have done is we have calculated one cubic polynomial for the given data. Means this y is equals to y is equals to 2x cube minus 7x square plus 6x plus 1 is there. No? This denotes the relation between the two variables involving in this solution, the question otherwise. So like this, by using interpolation, we are able to calculate the relation between the two variables. Otherwise, we can calculate the we can calculate any y value for the corresponding x value, like 2.9 or 0.9 like this. Okay. So this is all about interpolation in that first Newton's forward formula. So later on, after this, let us see one more example. Newton's forward difference formula. Here we have calculated the value. In the previous one, we have calculated the polynomial. Here we are calculating the y value for the corresponding x. So here they are asking us to find out f of 45. So the given x values are 40, 50, 60, 70 and 80, isn't it? So 45 falls where? Between 40 and 50. Means 45 is lying in first half. Right. So 45 is lying in first half. Then what happens? We should go with Newton's forward formula to find its corresponding y value. That is f of 45. So here, first let us write our Newton's forward formula. Here in this question, in the solution that we can instead of p as u. Means here the u is represented as x minus x naught divided by h. This is x naught. This is y naught, y1, y2, y3, y4. And this is delta y naught, delta y1, delta y2, and next one is delta y3. And this one is delta square y naught. Next one is delta square y1. Next is delta square y2. This is delta cube y naught, delta cube y1, delta power 4 y naught. So here you see y naught, delta y naught, delta square y naught, delta cube y naught, delta power 4 y naught. So after identifying all the information which are required to find out this y value, that is nothing but f of 45. Let us take Newton's forward formula. So what is this Newton forward formula? This is our required Newton's forward formula. In this formula, let us substitute everything. What is y naught? F of 40 means y naught plus p into delta y naught plus p into, otherwise u other here, u into u minus 1 divided by 2 factorial into delta square y naught plus u into u minus 1 into u minus 2 divided by 3 factorial into delta cube y naught, and so on. So till where we are supposed to take one more term, we are supposed to take y because delta power 4 y naught is there. And after putting all these values here, so if we calculate u, x is nothing but 45, x naught is 40, and the difference between successive x values is 5. It's 10, 40 and 50. So therefore 5 by 10, which is equals to 0.5. If you substitute all this, u, okay, delta y naught, delta square y naught, delta cube y naught, we are going to have our required f of 45 as 47.8672, and on approximation it is considered as 48. So like this, we are supposed to utilize Newton's forward formula for the calculation of required y value for the corresponding x value. Okay. So with this, we completed Newton's forward formula. And interpolation also we discussed. Introduction of interpolation with the Newton's forward formula we did with this video. Okay.